Now that we know how to find a vertical asymptote, let's look at horizontal and slant asymptotes. We're going to start by looking at horizontal asymptotes, but I do want to point out that I use the word or for a reason, because you can only have a horizontal or a slant asymptote, or neither really, but you can't have both a horizontal and slant asymptote in the same function. So again, we're looking at a rational function. A horizontal asymptote exists if f of x approaches d as x approaches infinity or negative infinity. So what does that mean? Because that's just a bunch of math gibberish, right? Let's look at what a graph might look like. I'm going to use kind of the same graph that I used on the last one. Let's draw, say, a vertical asymptote at x equals 3, and let's say my graph looked like this and this. Oops, that was sort of a bad one, but you get the idea. A vertical asymptote we already talked about. What I'm looking at now is the horizontal asymptote, which is I can see as I go very, very far to the left that my purple function there is getting closer and closer and closer to the value of 0, right? Because right here is a y value of 0. And as I go very, very far to the right, again, this purple line is approaching 0, but never touching it. So my horizontal asymptote would be y equals 0. Now, do I have to graph it to determine an asymptote? Of course not. I'm going to show you the mathematical way. What I have here are 3 different examples, and I want you to just notice one thing about it. This first one has x to the first on top and x squared on the bottom. So my degree of my numerator is less than the degree of my denominator. And when that happens, you're always going to have a horizontal asymptote at y equals 0, every time. When your degrees are the same, so this is a degree of 2, this is a degree of 2, so the degree of the numerator equals the degree of the denominator, then you're going to have a horizontal asymptote at, if I take those first 2 terms and reduce, that's where my horizontal asymptote is. So notice 2x squared over 3x squared reduces to 2/3. Y equals 2/3 is my asymptote, which means this line right here is y equals 2/3. If the degree of the numerator is greater than the degree of the denominator, which is what I have here, 3 on top, 2 on bottom, this is a slant asymptote. So let's talk about those. So you will have a slant asymptote if the degree of the numerator is exactly 1 greater than the denominator, so 3 and 2, that's 1 greater. And essentially what we're going to do is we're going to divide to find the slant asymptote, and I'm going to show you. In this case, I'm just telling you it's y equals 2/3 x. Notice that's different than the y equals 2/3. 2/3 x means I've got a slope of 2/3 on this guy right here. So let's do a step-by-step example together of how to find any of the asymptotes. So this question asks for horizontal or slant, either or any, for this particular function. So first thing I would do is compare the degree. The degree of the numerator is greater than the degree of the denominator. And because of that, I know that my horizontal asymptote is y equals 0. I know that because the degree of the numerator is less than the degree of the denominator. So that's all I had to look at. I didn't have to do any math there. And again, if I graphed it, and again, we could have found the vertical asymptotes by factoring the denominator into x plus 3, x minus 3, and that's where these 2 lines come in, as we talked about in our last video. But the one I'm looking for here is this guy right here at x equals 0. Notice as I go to the left, this function's getting closer to 0 but not touching. As I go to the right, this guy's getting closer to 0 and not touching. Let's look at another example. Hey, this one looks super familiar, except degrees of the numerator is equal to degree of the denominator. And when it's equal, how do I figure it out? Well, remember, all I'm going to do is take the first term, 3x squared, the term of the highest degree, divided by the term of the highest degree, and that gives me y equals 3. So I've got a y equals 3 asymptote. Again, if I look at my graph, that is where that black dotted line is at y equals 3. And again, you could find those same two vertical asymptotes, but we're focusing on horizontal right now. So let's take a look at the last one, because we haven't actually done one of these yet. On this one, I would have to, because the degree of the numerator is 1 higher than the degree of the denominator, I would have to divide. So what I'm going to do is I'm going to take x squared, I'm sorry, that's not right. I'm going to take 3x cubed, and I'm going to divide it by x squared minus 9. So I'm going to have to put plus 0x squared plus 0x plus 0 and see what happens. So to divide, I'm going to take x squared and say, well, I'm going to have to take that times 3x to get 3x cubed. And again, I could have done the 3x cubed divided by x squared to figure that out, just like I did before. That gives me 3x times x squared is 3x cubed. Minus 9 times 3x is minus 27x. These guys cancel because I'm subtracting, so I'm adding the opposite. 0 plus 27x is 27x. Bring down the 0. And notice x squared is a higher degree than 27x, so that 27x is just a remainder. So my answer would be 3x plus 27x over x squared minus 9. But my answer for my slant asymptote is everything except for the remainder. So y equals 3x is my slant asymptote, and that's this guy right here, y equals 3x, already graphed for you. Here's one for you to try. Again, take a look at the degree of the numerator and denominator to determine what kind of asymptote you have, horizontal or slant, and then figure out what is that asymptote. So again, I would look at the degree of the numerator is greater than the degree of the denominator. And so this one I actually have to do math for, right? This is going to be a slant asymptote. And for it to be a slant asymptote, I'm going to have to do some division. So I'm going to take 2x squared minus 0x minus 9. And I'm going to do x plus 1. I'm going to say x times 2x would give me 2x squared. So let's multiply everything by 2x. That would give me 2x squared plus 2x. I'm subtracting everything, so adding the opposite. That gives me 0 here and negative 2x. And this one I will have to keep going. So negative 2x minus 9. I'm going to look at x and negative 2x and say I'd have to multiply by negative 2. So negative 2 times x, negative 2x, negative 2 times 1, negative 2. I'm subtracting all of that, so I'm adding the opposite. And that gives me negative 7 as a remainder. I don't care at all about that remainder. What I care about is y equals 2x plus 2. I'm sorry, minus 2. Woo, I can't seem to write a minus sign. Goodness, 2x minus 2 is the equation of my slant asymptote. And as you can see here, this did not go through at 0, it went through at negative 2. It has a slope of 2. And so that is my slant asymptote for this particular function.